prime numbers only have two factors. 2 is a prime number. So 2 has a factor of 2 and a factor of 1. That's it. These numbers are prime if they only have two factors, 1 and themselves. Can anyone give us an example of another prime number that is divisible only by itself and by 1 and nothing else? 3 indeed. 3 is a prime number. Thank you very much. It only has two divisors, itself and 1. So 3, 3 and 1. 7, 7 and 1. 5, 5 and 1. All these numbers are prime. Good. Divisibility by 3. These are both important. Oh, of course, this is number 2, I'm sorry. Divisibility by 3. For example, 24 is divisible by 3 because the sum of the digits, 2 plus 4 is 6, 6 is divisible by 3. So divisibility by 3 requires add up the digits that you see in a number. If the resulting number, if that sum is divisible by 3, so is 24. So is the original number. If the sum is divisible by 3, so is the original number. What about 81? Is 81 divisible by 3? Yes, because 8 plus 1 is 9, and 9 is divisible by 3, therefore 81 is divisible by 3. What about 46? Is 46 divisible by 3? Perfect. No and yes. No, because 4 plus 6 is 10, and 10 is not divisible by 3. Good. The next one, item 3. Divisibility, of course, in order of prime numbers, 2, then 3. What is the next prime number that we are going to look at? Obviously, which one? Which one would be the next prime number?
11.
5. 5 is the next one. Good. So numbers are divisible by 5. Numbers are divisible by 5 if they end in 0 or 5. Very simple. So is 100 divisible by 5? Yes, because it ends in 0. Is 45 divisible by 5? Yes, because it ends in 5. Number 4, which in my opinion is not crucial by any means, because this is not a prime number. Divisibility by 6. Who cares? I don't consider it crucial by any means. A number is divisible by 6 if it's divisible by 2 and 3. So I already covered it here. Why would I even mention the rule separately? If it's divisible by 2 and it's divisible by 3, of course it's going to be divisible by 6. But let's write it, just for you to remember this. A number is divisible by 6 if it is divisible by 2 and 3. Of course. Is 46 divisible by 6? Is divisible by 2, but not by 3. So it's not divisible by 6. What about 36? Is 36 divisible by 6? It's an even number, so it's divisible by 2. The sum of the digit is 9, so it's divisible by 3, so therefore it's divisible by 6. I don't think that this is crucial by any means. I think 2, 3, and 5 are all that we need. You are going to see in the videos one more rule. Actually, 2 more. 5 divisible by 10. Numbers have to end in 0 to be divisible by 10. To be divisible by 10. But who cares? Because this is an even number, it's divisible by 2, and it ends in 0, it's divisible by 5. So this is not at all crucial. This is not at all crucial. Because by the time I get to 10, of course, most of the time I will look at 2 and 5. But yes, it's nice to remember, nice to know, if it ends in 10, it's divisible by 10. If it ends in 0, it's divisible by 10. Finally, one more. Again, not crucial at all. I don't consider this one interesting or super important by any means. Divisibility by 8. But who cares? Because I'm going to divide by 2. 3 times, but I'm going to divide by 2. So there is no need, to memorize this rule. Just so we have it here written down. If a number is divisible by 3, if the last 3 digits of the number, so if the number is A, B, C, D, these 3 digits form a number divisible by 8. So if the number B, C, D is divisible by 8, then the whole thing is divisible by 8. Okay? So if B, C, D as a number is divisible by 8, then the number A, B, C, D is divisible by 8. Who cares? There is no need for this. Okay, now let's talk about the prime factorization of a number. Give me a number, please. Think about a number. It can be in the hundreds, it can be in the tens, not millions or anything like that, just because we want to illustrate how to find the prime factorization of a number.
96.
Okay, perfect. Excellent. And remember, we have to start low from the first prime number. Should I? Yes, because the number is an even number, so I know it's divisible by 2. Please divide 96 by 2 and tell me what is left. It's a quotient. Is it 48? Yes, correct? Perfect. I continue. I go back to the first prime number. Of course, 2. Please divide 48 by 2 and tell me what is left. Okay? It's an even number, so it's divisible by 2. Please divide by 2 and tell me what is left. Good, excellent. So it's an even number, so we divide by 2. Please let me know what is left. Perfect. It's divisible by 2 because it's an even number. And tell me, please, what is left.
3.
Excellent. Now we only look at the ends of this prime factorization tree. This is a tree. A prime factorization tree. The endpoints. Only the endpoints. And this is the prime factorization of 96. What is it? 1, 2, 3, 4, 5 2's. 2 to power 5. We're going to talk about that expression in detail. Multiplied by 3. So the prime factorization, so this is a prime factorization tree. And remember,
How did we get to 48?
9 divided by 2 is 4. 4 times 2 is 8. Carry a 1. 1, 6 divided by 2 is 8.
Oh, okay, because 9 divided by 2 is 4.5, and thank you, I was wondering how I got 48.
Is it okay? Even if there is no mistake here, I'd rather go back and check. So please always feel free and say, I think there is an error, and I will go back and check. Maybe you see something that I don't. Don't ever be scared or reluctant to say something, ever. Is this okay? So 2 times 8 is 16. 6 and carry 1. 2 times 4 is 8. Plus 1 is 9. Is that okay, everyone?
Yeah.
Okay. So we only count the prime numbers. You cannot say that 96 is 4 times 2 to the third times 3. No, 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 no. These factors have to be prime numbers. 2, 3, 5, 7, 11, 13. Never 4, 6, 10, 9, 12. There is no such thing. So that's why we have them circled. These are the ends of the branches if you want. And they're all prime numbers. And now I have 5 2's, which means power 5, and 1 3, which means power 1. Any questions? Would you like to practice the prime factorization with another number, or we move on? We're going to get to examples starting from now. Anyone would like to pick another number?
72.
Very good. Let's look at 72. Excellent. It's a prime number. I'm sorry. It's an even number, I meant to say. The first prime number is 2. I divide and I get 36. Let's check. 2 times 6 is 12. 2 and I carry 1. 2 times 3 is 6. Plus 1 is 7. 36 is an even number. So I have to start back from 1. Back from the first prime number, which is 2. Good. So then I have 18. Again is a even number. So I have to start or continue with 2. And then I get 9. Now I can no longer continue with 2 because 9 is not an even number. I have to move on to the next prime number. After 2, what is the next prime number that I have to try? Good. Times 3. I circle the ends of the branches of the tree. Can anyone give us the prime factorization of this number? It's okay if you're wrong. Ashley, what do you think? You are muted. Okay, Ashley is not with us. Oh, Ashley is with us. Say it again.
2 to the power of 3 times 3.
How many trees do you see?
2.
Yes. So indeed, 2 to power 3 times 3 to power 2. This is the prime factorization. Thank you very much. 2 to the power 3 times 3 squared. This is the prime factorization of 72. Any questions? Are we okay with this? Does anyone need more examples? Can we move on? Okay. In the following example, let's say we have 4 multiplied by x equals negative 12. I would like to find x. This is something called equation. An equation has one left-hand side, one equal symbol, and one right-hand side. You cannot continue simplifying or doing anything to the sides. You have to continue after this operation. You continue with another operation underneath and another operation underneath till you finish and find x. We cannot go left and right. Good. Because 4x means 4 times x, as I mentioned it here, the only way to find x is to divide both sides by this number in front of x. When we divide both sides by x, what do we get on the left-hand side? Well, the answer is simple, just x. That's why I'm dividing by 4 and not by 15. So I divide both sides by 4 because I want to determine x. Okay, perfect. So I divide this side by 4 and I get x. Can anyone divide negative 12 by 4? Now this is a simple division. But what if I have something more complicated? I will do this. Please watch what I'm doing. This is a very simple example. Yes, we are not going to do this, but I want to use a simple example to show you how we use the factorization or how we eliminate factors. Okay, so I'm going to write something very important here. We simplify only factors. Again, this very important keyword. Keyword. What does this mean? It means this. That if I have the operation 3 plus 6 divided by 6, I will never, ever, ever be allowed to simplify this 6 from the top with this 6 from the denominator. Why? This one here is a factor. But this one here is not a factor. How do we call it? Because it's added to another one. How do we call this? Lindsay, will you tell us? What do you think? You're muted. Okay, Lindsay is not with us. Pavlos, what do you think? Okay, Pavlos is not with us. Alan, what do you think? You're muted. Okay, Alan is not. Okay, yes, what do you think? You're muted again.
What was the question?
Yes, so how do we call this quantity here that is added to 3? This one is called a factor because it's 1 times 6. But how do we call this quantity here? Thank you, Rachel. So this is called a term. Since I cannot see you, I will not be able to give you credit for today. So if you turn on your cameras, I will be able to give you credit for today. Not absent, you will not be absent, but you will not get credit for today. I don't know if you're here. I don't know if your grandma is representing you, which I love grandmas, by the way. So if I can't see you, I can give you credit for today, so you know. So because we only simplify factors, this is not a factor. So this will be a terrible mistake to simplify a term with a factor. So please never ever do this. If somebody does this, it needs a lot of discussion, and it means that the student has not studied algebra at all. Okay? So please understand, we only simplify factors. So coming back to my simple example, I know the answer, but I just want to show you how this works. Both are even numbers. I start from 2. 12 divided by 2 is 6. But I have to divide the denominator also by 2. 4 divided by 2 is 2. Now I continue because 6 and 2 are divisible by 2 as well. So 2 divided by 2 is 1, and 6 divided by 2 is 3. What is left? 1 in the denominator, 3 in the numerator, and negative sign. So the final answer is negative 3, which we knew. We didn't have to do this. But I just wanted to show you, in case we have big numbers and the answer may not be an exact answer. Yes, you can use the calculator, fine. But this is even more important to understand how to simplify. Now, how do I know that this is a correct answer? I don't know. I have no idea. I don't need anyone to tell me yes or no. I will go back, replace it in the original equation, and see if I get a true statement or I get something like this. If I get something like this, my answer is wrong. This is false. But if I get 5 equals 5, 0 equals 0, 10 equals 10, then I'll say good. That's good. 4 times negative 3 is negative 12. The left-hand side is negative 12. The right-hand side is negative 12. I'm done. I know that this is the correct answer, and I'll say yes. I checked. Any questions? Any questions? Okay, here's another one. 9 divided by x equals negative 3. What should I do now? Well, when I had multiplication, I used the opposite operation. I divided. Now, I see division. What will be the opposite operation? The one that takes care of division. The one that took care of multiplication was division. Which one will take care of the division?
Multiplication.
Absolutely. Thank you very much. Or, since we discussed this already, this is what I'm going to do. What did I just create? What is it called? Yes, you have to look it up because this is a new terminology and we're building on the vocabulary now. Of course, what is it?
Would it be a proportion?
Indeed. And I'm happy because in a proportion I can do what I can never do in anything else. I can cross multiply. So 9 times 1 is 9 equals negative 3 times x, which is negative 3x. And I am back to this situation. Very simple. What will you do now? What will be the next step here? Yes, I will be dividing both sides by. It's always the number that is in front of x. So I cannot, although you can do it in 2 steps, but please do not separate the number from the sign in front of it. It belongs to it. So yes, I will be dividing by -3. Notice that on the side, because I'm going to talk about this as well, we are not allowed to, and there is an example in the book and in your homework that I totally disagree with, and I'll give you the example. We are not allowed to write two operation symbols without being separated by parentheses. This is incorrect. So notice that I had the division symbol, then I put parentheses and -3. I don't have to do that for +3. But I have to do it and separate division from subtraction. By parentheses. And you can say, why are you using grouping symbols? They are the grouping symbols, but there are no operations inside. So right now, we are using parentheses only, not because we have operations to perform inside, but only because we have to separate two operation symbols. Okay, perfect. So then x equals, can anyone give us the final answer of this division?
-3.
Yes, indeed. Is it true? I don't know. But I'm going to go back and replace it. And when I multiply two negative numbers, just two, because if I multiply three negative numbers, it's a different story. But when I multiply just two negative numbers, negative times negative will be positive, so then I'll say yes. -3 times -3 is indeed 9. Everything is perfect. Okay. Good.